Okay, Alex, this right here is for you. We are going to calculate this double integral over D, and D is the region in the third quadrant between this and that. And before I continue, let me just tell you guys, remember to check out Dr. Payan's videos if you would like to have more resources in Calculus 3 and also linear algebra. In fact, I forwarded this question to him, and he just told me to polar coordinate. And in fact, I was being lazy. I just want him to do the video, but I will do it for you guys, especially Alex. I have some time today, so why not? Alright, so let's talk about what D is first. Well, it's a circle right here with radius 1, and this is a circle with radius 3, and we are in the third quadrant. So let me just draw a picture right here for you guys real quick. We have a circle right here with radius 1, and then a bigger circle with radius 3. And now you have a pokeball. And then we just want this part in the third quadrant. And we will be using the polar coordinate, so be sure you know the theta going from pi to 3 pi over 2. And then this right here is 1, and this right here is 3. Right? So R goes from 1 to 3. And then the other things that you guys have to know is, remember to change from rectangular to polar, or Cartesian to polar, or Cartesian form to polar form. You will have to remember that x is equal to R cosine theta, and then y is equal to r sine theta. And then lastly, remember dA right here is a dx dy, and let me just write it down. dA is the dx dy. You have to do some Jacobian business. This right here is r dr d theta for the dA. Alright? And you guys can also get my shirt, the Gaussian integral shirt, and you'll see this right here over there, right? That's kind of cool. Now, we'll be calculating this integral, of course. We'll take this integral into the r and theta world, and then we'll see what happens over there. So here we go, integral. And let me just write down everything inside first. So we have y squared, and let me just write that down. Y is r sine theta, and then we are going to square that, and then we add it with 3 times r cosine theta, like this. And then, again, remember dA, a small common mistake is that people forgot the r, and then the dr d theta. And since I wrote this down like this, I'll put down r value, meaning going from 1, 2, 3. Okay, 1, 2, 3 for the limit of integration of the r. And then theta is going from pi to 3 pi over 2, like this. And then the rest is just doing a lot of algebra, well, a lot of integrals, I mean, and then some work. That's all. So here we go. I'll keep the integral in this order. There's no reason for me to really change the order whatsoever. So pi to 3 pi over 2. And then, let's see, we have 1, 2, 3, and let me just clean the things up inside. When you square this, you get r squared, but you multiply by another r, so you get r cubed, and then you have sine squared theta, and then this right here, multiply by r, so you get plus 3r squared times cosine theta, and then we took care of the r already, so we have the dr here, and then the d theta. And now we'll be integrating this. So the outside integral from pi to 3 pi over 2 stays. And then integrating this guy, integrating this, we get 1 over 4 r to the 4th power, and this stays. Because theta is like a constant in the r world, so this right here stays. So we have sine squared theta. Integrating this, you add 1 to the power and divide it by the new power, which is 3. Divided by 3, they cancel. So we get plus r cubed cosine theta, like this. And then we will have to plug in 1 to 3, and then d theta on the very outside. Now, let's see. Here is the deal. We'll do some computations in our head. Otherwise, this is going to be really long, so let's see. When you plug in 3 into the r and r, 3 to the 4th power is 81. And then over 4, right? And then this right here is going to be 27. And then you're going to minus when you're putting 1 into here and here. Well, when you're putting 3 is 81 over 4, minus 1 over 4, which is 80 over 4, which is 20, right? So altogether, when you do that, you will end up with 20. And then this right here, the sine square theta stays 27 minus 1 is 26. So you have plus 26, and this right here, cosine theta stays, and then you still have the integral to take care of from pi to 3 pi over 2 right here, right? And then you just continue. This right here is not that bad. Not really. This right here, you have to do some identity business. So to take care of this, you're going to use a power reduction formula. If you want to see how to do more integrals, be sure you guys go check out my 100 integrals. So this right here is, of course, one of the ones that you have to know. All right, here's the deal. Sine right here, let me just put this down in purple for you, in blue for you guys, I'm sorry. This right here is equal to 1/2 times 1 minus cosine of 2 theta, like this, right? So when you do 20 times 1/2, of course, is 10. And then, of course, you will just kind of clean things up a little bit. And I'll write this down again for you guys to make it slightly more clear. We go from pi to 3 pi over 2. This pi is not that good. Let me just see. Imagine if I do like 100 double integrals in one video. I don't know how long that will take. But anyway, that's 10. 10 times 1 is still 10. And then still 10 times that, so we have minus 10 cosine of 2 theta, like this. And then this right here is plus 26 cosine theta, right? D theta. Aha, I have another integral sign for you guys. So cool, huh? Anyway, integrating 10 in the theta world, we will end up with 10 theta. Remember, integral of cosine is positive sign, right? So the minus will stay, and you will get minus sign. So let's put that down. Minus sign. And the input stays, right? So you have this, right? But you have to remember the chain rule.
Use the chain rule.
The derivative 2 theta is a 2. So be sure you divide it by 2. So 10 divided by 2, you get 5 right here. And then for this part, integrating 26 cosine, we get plus 26 sine theta, like this. And then we are going to be plugging. So we have to go from pi to 3 pi over 2, right? And now here's the deal. When you put 3 pi over 2 into the signs here and here, guess what? This right here will give us 0 because you end up with sine of 3 pi, which is going to be 0. And when you put in 3 pi over 2 right here, we will end up with -1 because the sign value right here is -1, right? So let's see. Just plugging, and then I'm not going to show you guys all the plugging, all that. This is like Cal 3 already, right? So the first one I do have to show you though. So we have 10 times 3 pi over 2. And then minus, when you plug in 3 pi over 2 into here, it's going to be 0. And then we are going to add 26, but then sine theta, when theta is this, we get -1. So technically, we have to multiply by -1, like that. That's the first part. And then we're going to subtract. When you put in pi, we get 10 pi. And then when you put in pi right here, guess what? Sine of 2 pi is 0, so this is gone. Likewise, this is also gone, sine of pi is 0, so that's gone. So we have to -0 plus 0. Very nice. In the end, let's see, this is going to give us 5, and then times 3 pi is 15 pi. 15 pi minus 10 pi, we get 5 pi. And then minus 26. Just like that. Yeah, so in the end, the answer to that integral is 5 pi minus 26. Really bizarre answer, huh? But really cool too. And yeah, that's it. So if you guys are new to my channel, be sure to subscribe and also go check out Dr. Pan's video. Thank you guys so much. And as always, that's it.